The discussion surrounding the potential dangers of biological weapons compared to nuclear weapons has gained significant traction, particularly in the wake of global health crises and advancements in biotechnology. This report consolidates various perspectives on why biological weapons may be considered more terrifying than nuclear weapons. 1. Self-replication and contagion. One of the most alarming aspects of biological weapons is their ability to self-replicate. Unlike nuclear weapons, which have a defined explosive yield and limited geographical impact, biological agents such as viruses and bacteria can spread exponentially through populations. Historical examples such as the 1918 influenza pandemic and the recent COVID-19 outbreak demonstrate how quickly pathogens can proliferate across the globe, resulting in widespread devastation. In contrast, nuclear weapons typically affect a limited radius, with immediate destruction confined to several kilometers from the blast site. 2. Unpredictability and mutability. Biological weapons pose a unique challenge due to their unpredictable nature. Pathogens can mutate, rendering containment efforts ineffective and causing them to spread uncontrollably. This fear is compounded by the fact that biological weapons do not discriminate between friend and foe. They can inadvertently harm the populations of the very nations that deploy them. Experts have pointed out that the unpredictability of biological agents can instill a sense of dread in military strategists who may find it challenging to anticipate the outcomes of deploying such weapons. 3. Global impact potential. While nuclear weapons can cause immediate and catastrophic destruction, the long-term effects of biological weapons could potentially be more far-reaching. A highly contagious and lethal biological agent could lead to a pandemic that decimates populations worldwide. Some experts argue that a new biological weapon with high transmissibility and mortality rates could theoretically wipe out a significant portion of humanity, surpassing the death toll that would result from even the largest nuclear exchanges. 4. Impact on non-human life. Biological weapons are not limited to human targets. They can also be engineered to attack crops and livestock, disrupting food supplies and causing economic instability. This aspect highlights the strategic versatility of biological weapons, as they can undermine an adversary's agricultural base, leading to famine and societal collapse. Nuclear weapons, although devastating, primarily target infrastructure and population centers, with less direct impact on agricultural viability. 5. Long-term environmental consequences. While nuclear weapons leave behind radiation that can be monitored and managed, the long-term ecological impacts of biological weapons are less clear. An uncontrolled biological agent could disrupt ecosystems, leading to unforeseen consequences on biodiversity and environmental health. The potential for a biological agent to escape containment and establish itself in wild populations poses a risk that could compound over time, making it difficult to predict or mitigate. 6. Historical context and social perception. Historically, biological warfare has been employed in various forms, from the use of plague-infected corpses during sieges in medieval times to modern-day bioweapons research. The impact of diseases such as smallpox has historically caused massive population declines, illustrating the potential of biological agents to inflict harm on a global scale. In contemporary society, the perception of biological threats has shifted due to the ease of travel and globalization, making the spread of infectious diseases more likely. 7. Comparison with nuclear weapons. Despite the overwhelming destructive power of nuclear weapons, some argue that their sheer number and the global understanding of their consequences make them somewhat more controllable. The doctrine of mutually assured destruction has historically acted as a deterrent against their use. In contrast, the potential for biological weapons to be developed by rogue states or non-state actors who lack the same level of deterrence complicates the security landscape. The accessibility of biotechnological tools further blurs the line between legitimate research and weaponization. 8. Ethical and moral considerations. The ethical implications of using biological weapons are profound. Deploying a biological agent can lead to indiscriminate suffering, raising moral questions about the justification of such actions in warfare. The psychological effects of a biological attack, including fear and panic, could destabilize societies even before the physical effects manifest. In contrast, the use of nuclear weapons, while catastrophic, is often viewed through the lens of military strategy and deterrence. Conclusion. In summary, the consensus among experts suggests that biological weapons, due to their self-replicating nature, unpredictability, potential for widespread impact, and ethical ramifications, may indeed pose a greater long-term threat to humanity than nuclear weapons. As advancements in biotechnology continue, the global community must remain vigilant and proactive in addressing the risks associated with biological warfare, ensuring that appropriate safeguards and regulations are in place to prevent catastrophic outcomes. The threat of biological weapons is not merely a hypothetical scenario, it is a pressing concern that requires comprehensive strategies for management and response. Biological weapons are often considered more terrifying than nuclear weapons for several counterintuitive reasons that challenge conventional thinking about the nature of warfare and the consequences of mass destruction. 1. Self-replicating nature. Unlike nuclear weapons, which deliver a one-time localized explosion, biological weapons can replicate and spread themselves. This self-replicating ability means that a small initial release can lead to a global pandemic reminiscent of historical events such as the 1918 influenza pandemic or the COVID-19 pandemic. The ability of a virus or bacterium to infect hosts and multiply exponentially presents a threat that can outpace any immediate response, making it a unique challenge in warfare. 2. Unpredictability and mutation. Biological agents are inherently unpredictable. They can mutate over time, potentially becoming more virulent or transmissible. This characteristic is in stark contrast to nuclear weapons, where the effects and fallout patterns can be modeled and predicted with a degree of accuracy. The uncertainty surrounding how a biological agent will behave once released creates a level of fear that nuclear strategists do not typically face, as the outcomes of nuclear detonations are more straightforward to gauge. 3. Global reach and indiscriminate impact. The potential for biological weapons to cause harm on a global scale is greater than that of nuclear weapons, which have a more limited immediate impact radius. A biological weapon can infect individuals far from the original release point, thereby causing widespread illness and death without regard for national borders. This indiscriminate nature means that even the attacking nation could suffer from the consequences, as seen in discussions about the potential backfiring of a biological attack. For long-term effects, while nuclear weapons can cause immediate destruction and radiation sickness, biological weapons can lead to long-term health crises, economic disruption, and societal collapse. The lingering effects of a pandemic, such as healthcare systems being overwhelmed, loss of workforce, and lasting psychological impacts, can destabilize societies in ways that the immediate destruction from a nuclear explosion might not. 5. Targeting of ecosystems. Biological weapons can also be designed to target agricultural systems, leading to food shortages and economic collapse. By affecting crops or livestock, such weapons can create famine and destabilize nations without the need for direct confrontation. This contrasts with nuclear weapons, which primarily focus on immediate human casualties and infrastructure destruction. 6. Control and containment challenges. Once a biological weapon is released, it is nearly impossible to contain. The historical example of anthrax spores released on Gruinard Island during World War II, which rendered the island uninhabitable for decades, illustrates the long-term containment challenges posed by biological agents. In contrast, the immediate aftermath of a nuclear strike, while catastrophic, allows for more defined cleanup and recovery efforts. 7. Psychological warfare. The fear associated with biological weapons can be a powerful tool in psychological warfare. The idea that a virus could be unleashed without warning and spread silently among populations can create widespread panic and societal breakdown. This psychological aspect may not be as pronounced with nuclear weapons, which, while terrifying, are often viewed in the context of strategic deterrence. 8. Historical precedents, historical instances of biological warfare, such as the use of plague-infected corpses during sieges, highlight the potential for mass casualties through biological means. The Black Death, which decimated a significant portion of Europe's population, serves as a reminder of the devastating impact infectious diseases can have, a scenario that could be replicated with modern biotechnology. 9. Technological advances in bioweapons. Advances in genetic engineering and synthetic biology raise concerns that future biological weapons could be designed to be more lethal or resistant to existing treatments and vaccines. This aspect of biological warfare is particularly alarming given the rapid pace of scientific advancements, which could allow rogue states or non-state actors to develop highly sophisticated pathogens. 10. Comparative destruction potential. While nuclear weapons possess immense immediate destructive power, the argument that biological weapons could potentially wipe out a significant portion of humanity over time is a chilling counterpoint. Theoretical discussions suggest that a highly contagious and lethal biological agent could theoretically eradicate humanity or cause catastrophic societal collapse in a way that conventional nuclear exchanges might not. In conclusion, while nuclear weapons are often viewed as the most devastating tools of warfare due to their immediate destructive capabilities, biological weapons present a complex array of threats that challenge this notion. Their ability to replicate, mutate, and spread uncontrollably, combined with their historical precedents and potential for long-term societal impact, positions them as a uniquely terrifying form of warfare that warrants serious consideration and vigilance. The debate over whether biological weapons are more terrifying than nuclear weapons has garnered significant attention, particularly in light of historical pandemics and recent global health crises. While the destructive power of nuclear weapons is widely acknowledged, the subtleties and complexities of biological weapons often lead to underestimation of their potential dangers. Below are key aspects of this topic that may be overlooked along with their significance. 1. Self-replication and spread. One of the most critical and often overlooked aspects of biological weapons is their ability to self-replicate and spread uncontrollably. Unlike nuclear weapons, whose effects are localized, and immediate biological agents can multiply and disseminate over vast distances. This ability was starkly illustrated during the 1918 influenza pandemic and the COVID-19 pandemic, where viruses crossed borders, rapidly leading to global crises. Significance: the self-replicating nature of biological agents means that a small initial outbreak can lead to a pandemic, threatening entire populations without the need for direct military engagement. This makes them not only a weapon of mass destruction but also a tool for asymmetric warfare, where a less powerful entity can inflict devastating damage on more powerful nations. 2. Unpredictability and mutation. The unpredictability of biological agents poses a significant threat. Pathogens can mutate, potentially becoming more virulent or resistant to treatments. This aspect of biological warfare is troubling for strategic planners who must consider not only the initial impact but also the long-term consequences of an outbreak. Significance: the ability of biological agents to evolve means that containment measures may fail, leading to unintended consequences, including the infection of one's own population. This unpredictability can create a sense of chaos and fear, complicating response efforts and leading to societal instability. 3. Impact on agriculture and livestock. Another dimension often overlooked is the potential use of biological weapons against agricultural systems and livestock. Agents that target crops or livestock can devastate food supplies, leading to famine and economic collapse without direct military confrontation. Significance: targeting agriculture can be a strategic move to weaken an adversary without the need for conventional warfare. The long-term consequences of such attacks can be more detrimental than immediate destruction, leading to social unrest and mass displacement. 4. Moral and ethical implications. The ethical considerations surrounding the use of biological weapons are complex. While nuclear weapons have been subject to international treaties and moral scrutiny,
biological weapons often escape the same level of attention.
The moral implications of deploying a weapon that can indiscriminately affect both enemies and allies raise significant concerns. Significance: the lack of robust international regulation on biological weapons compared to nuclear weapons creates a dangerous gap. This inconsistency in global governance could potentially encourage the development and use of biological weapons given their perceived lower immediate impact compared to nuclear weapons. 5. Historical precedents and lessons. Historical instances such as the use of plague-infected corpses during sieges or the deliberate spread of smallpox among indigenous populations illustrate the devastating effects of biological warfare. These lessons highlight the long-term impacts of biological agents on human populations and societies. Significance: understanding historical precedents can inform current policies and preventative measures. The historical context underscores the importance of preparedness and the need for international cooperation to prevent the misuse of biological technologies. 6. The role of modern technology. Advancements in biotechnology and genetic engineering have made the creation of tailored biological weapons more feasible. The potential for creating pathogens that can target specific populations or that possess enhanced transmissibility raises alarm. Significance: the ease of access to biotechnological tools can empower rogue states or non-state actors to develop sophisticated biological weapons which could lead to unprecedented threats. This democratization of bioweapon capabilities necessitates rigorous monitoring and preventive measures. 7. Comparison of destruction mechanisms. While nuclear weapons deliver immediate explosive destruction, biological weapons inflict damage over time, often leading to slow and painful deaths. The psychological impact of a biological outbreak, fear, panic, societal breakdown, can be more insidious than the immediate devastation wrought by nuclear explosions. Significance: the long-term psychological and societal effects of biological weapons can destabilize nations and communities, leading to a protracted state of fear and uncertainty. This raises the stakes in discussions about defense strategies and public health preparedness. 8. Global health security and preparedness. Biological threats underscore the importance of global health security and preparedness. The COVID-19 pandemic has highlighted vulnerabilities in health systems worldwide, illustrating that a biological attack could exploit these weaknesses. Significance: strengthening global health systems and preparedness can mitigate the risk associated with biological weapons. Enhanced surveillance, rapid response capabilities, and international cooperation are crucial in addressing both natural and man-made biological threats. Conclusion: while nuclear weapons remain a significant threat due to their capacity for immediate destruction, the complexities and potential horrors of biological weapons often lead to their underestimation. The self-replicating nature, unpredictability, historical precedents, and modern technological advancements surrounding biological agents create a multifaceted threat landscape that requires careful consideration and proactive measures. Understanding these nuances is essential for policymakers and global leaders in crafting effective strategies to prevent the misuse of biological weapons and to enhance global security. For valuable points for in-depth analysis and discussion on biological weapons compared to nuclear weapons. 1. Self-replication and global spread. One of the most significant advantages of biological weapons over nuclear weapons is their ability to self-replicate and spread uncontrollably. Unlike nuclear weapons, which have a defined and limited radius of destruction, biological agents, such as viruses and bacteria, can propagate exponentially, leading to pandemics. Historical events like the 1918 influenza pandemic and the COVID-19 pandemic illustrate how rapidly and unpredictably diseases can spread across the globe. This self-replicating characteristic means that a small initial outbreak can escalate into a worldwide crisis affecting both enemy and ally populations indiscriminately. The implications for military strategy and public health are profound, raising questions about quarantine measures, containment strategies, and international cooperation in disease management.
2. Unpredictability and mutation. The unpredictability of biological weapons is another critical point of concern.
Pathogens can mutate and evolve, potentially leading to new strains that are more virulent or resistant to treatment. In contrast, the effects of nuclear weapons are more predictable, with established models for their immediate impact and long-term consequences, such as radiation fallout. The fear of a biological agent mutating beyond control adds a layer of anxiety for military and government planners, who must consider not just the initial deployment but the potential for a weapon to change form and escape containment. This unpredictability complicates risk assessments and necessitates robust biosurveillance systems to monitor outbreaks and mutations. 3. Wider scope of impact. Biological weapons can have a broader scope of impact beyond human casualties. They can target agricultural systems, leading to food shortages by devastating crops or livestock, thereby undermining a nation's food security and economic stability. The potential for agricultural bioweapons to create famine and social unrest presents a multifaceted threat that nuclear weapons do not pose. While nuclear weapons can certainly devastate cities and cause immediate loss of life, their long-term environmental effects, such as nuclear winter, are relatively easier to model and predict.
Conversely,
the cascading effects of a biological attack, including the socioeconomic fallout from widespread illness and food supply disruptions, can be more challenging to anticipate and manage. 4. Ethical and control concerns.
The ethical implications of deploying biological weapons raise significant concerns.
The nature of biological agents means that once released, the controlling entity may lose the ability to manage the outbreak, potentially harming their own population in addition to enemy combatants. This contrasts sharply with the targeted destruction afforded by nuclear weapons, which can be deployed with a specific target in mind. The moral and ethical considerations surrounding the use of biological weapons are compounded by the potential for accidental release or misuse, raising questions about the responsibilities of states and non-state actors in preventing biowarfare.
This necessitates a discussion on international norms, regulations,
and the need for stringent biosafety protocols in research involving dangerous pathogens. These points highlight the complexity of comparing biological and nuclear weapons, emphasizing the unique challenges and threats posed by biological warfare in the modern context. The discussion can lead to deeper insights into international security, public health preparedness, and the ethical frameworks that govern the use of such weapons. 1. The Black Death 1347–1351. This pandemic is one of the most famous instances of biological warfare, although it was not used intentionally. The Black Death, caused by the bacterium Yersinia pestis, decimated Europe's population, killing an estimated 25 million people, around one-third of Europe's population at the time. Notably, during the Mongol siege of Kaffa in 1347, plague-infected corpses were catapulted over the city walls, spreading the disease to the inhabitants and eventually to Europe.
This event showcases how biological agents can be used strategically in warfare, highlighting their potential for widespread devastation.
2. The Japanese Unit 731 experiments 1937–1945. During World War II, Japan conducted secret biological warfare experiments under Unit 731. The unit engaged in horrific human experimentation, infecting prisoners of war and civilians with various pathogens, including plague and anthrax, to study the effects of these diseases.
These experiments aimed to develop biological weapons for use in warfare. The results had the potential for mass casualties if deployed. This case underscores the terrifying potential of biological weapons and the ethical violations that can occur in their development and use.
3. The Anthrax Letters 2001. Following the September 11 attacks, a series of letters laced with anthrax spores were sent to several news media offices and two Democratic senators, Tom Dashley and Patrick Leahy. The letters resulted in 5 deaths and 17 infections.
This incident highlighted the threat posed by biological weapons,
especially when used by individuals or small groups. The anthrax attacks instilled widespread fear and demonstrated how biological agents can be employed to cause panic and disruption on a large scale, echoing the broader concerns regarding the use of biological warfare. The future outlook regarding biological weapons poses significant concerns for global security and public health. As technology advances, the potential for biological weapons to surpass the destructiveness of nuclear weapons becomes increasingly plausible. Here are some predictions for the future concerning biological weapons. 1. Advancements in biotechnology. With the rapid development of genetic engineering and synthetic biology, the possibility of creating highly infectious and lethal pathogens will grow. As techniques like CRISPR gene editing become more accessible, malicious actors may find it easier to engineer biological agents that could evade current vaccination protocols and public health measures. 2. Increased risk of bioterrorism. The accessibility of bioweapons technology may lead to an increase in bioterrorism incidents. Non-state actors and rogue individuals could exploit biologically engineered pathogens to instigate chaos, targeting civilian populations with diseases that spread rapidly and indiscriminately. 3. Global pandemic preparedness. The COVID-19 pandemic has highlighted the world's vulnerability to biological threats. In the future, nations may invest more heavily in pandemic preparedness, including surveillance systems to detect outbreaks, early stockpiling vaccines and antiviral medications, and developing rapid response teams to control potential outbreaks before they escalate. 4. International regulations and treaties. As the threat of biological weapons becomes more pronounced, there may be a push for stronger international regulations and treaties governing biological research and the use of synthetic biology. Existing frameworks like the Biological Weapons Convention may need to be updated to address the evolving landscape of biological threats. 5. Public health infrastructure. Countries may prioritize strengthening their public health infrastructures to minimize the impact of biological attacks. This will likely include enhancing laboratory capabilities, increasing funding for research on infectious diseases, and improving healthcare systems to handle surges in cases resulting from biological warfare. 6. Ethical and moral dilemmas. As biotechnology progresses, ethical considerations regarding the manipulation of pathogens will become increasingly complex. Societies will grapple with moral questions surrounding dual-use research, where scientific advancements can be used for both beneficial and harmful purposes. 7. Vaccine development and distribution. In response to the threat of engineered biological weapons, there will be an accelerated focus on developing universal vaccines that can provide broad protection against multiple strains of pathogens. Additionally, strategies for rapid distribution of vaccines in the event of an outbreak will become a priority. 8. Impact on warfare strategies. Military strategies may evolve to incorporate biological weapons as a means of asymmetric warfare. The unpredictable nature of biological agents could lead to a paradigm shift in how nations approach conflict, with a greater emphasis on biological threats in military training and preparedness. 9. Public awareness and education. Increased awareness about the potential dangers of biological weapons will likely lead to public education campaigns on biosecurity and personal health measures. Communities may become more vigilant in recognizing symptoms of infectious diseases and understanding the importance of vaccination. 10. Collaboration between nations. The global nature of biological threats necessitates collaboration among nations. There may be increased international partnerships for intelligence sharing, research collaboration, and coordinated responses to biological incidents, potentially leading to a more unified global approach to biosecurity. Conclusion. The future of biological weapons presents both challenges and opportunities for global security. While the potential for devastating impacts exists, proactive measures in research, public health, and international cooperation can mitigate the risks. As we move forward, the balance between scientific innovation and ethical responsibility will play a crucial role in shaping a safer world.